Hey guys, this is video 17 on differential equations and slope fields. So when we first started differential equations, first of all we talked about differential equations are just equations with derivatives basically, right? First and second derivatives. And then we talked about slope fields, and slope fields are basically saying, okay, if I don't have a function, I don't know what my function is, and I want to graph it, I can take each point and find the slope at that point using my differential equation, and then I'll be able to connect them to get a general curve. And then if I have a initial condition, then I can also find my particular solution. So the slope field here, it's important to be able to just know how to do this. dy dx is equal to negative y over x. I'm going to do it for probably 4 or 5 points, but you should be able to do it for all of the points they give you. So I'm going to do it for the blue points that I make. I'll do it for 0, 0, 1, 1, 1, 0, 0, 1. Maybe I'll do the 9 points around there. Okay, so what do we got here? So we have dy dx, so I'm going to show my work for all of them. Dy dx at the point negative 1, 1. I'll go from left to right. So negative 1, 1. That's going to be equal to, we have negative y, so negative 1 over x, that's just 1. So when I draw my slope here, I'm going to make sure I draw it. If I were to draw a line with a slope of 1, it would look like that because it would go through those 2 points, right? So I'm going to draw a piece of my slope field with the exact same slope. So it's really important to make sure your slopes are pretty accurate because you don't want to, it could affect you later on. So dy dx, now let's go across. So I'm evaluating this at the point 0, 1. So I have y is negative 1 over 0, so that's undefined. So if it's undefined, I don't do anything to it. Do not make a horizontal line. Don't do anything to it. It means it has nothing there. Now dy dx at the point 1, 1. That's going to be negative 1 over 1, which is just negative 1. So now my slope is decreasing, and again, I want to draw it so that it's pretty accurate, and it looks like it would go to that next point. It's a little hard for me to draw on this iPad, but you got it. And then, alright, so let's go to the next row. I'll change colors so this way you can keep up with me. dy dx is being evaluated at the point negative 1, 0. So that's going to be 0 on top for my y, and then I have a negative 1, so that would be a positive 1. So I have 0 over 1 is just 0. If I have 0 slope, I'm going to draw a horizontal tangent line, right? So that would show me that my slope is 0. dy dx at the point 0, 0. Well, that's going to make my x value 0, which is going to make it undefined, so I'm not going to have anything there. And dy dx evaluated at 1, 0 is going to be, in the top again I have 0 over, now negative 1 is just 0. So I have a horizontal tangent line there also. And the bottom 3 points, dy dx evaluated at the point negative 1, 1 is going to be my y value is negative 1 over, or we'll make it negative times negative, so we'll make it positive 1. Over negative 1 is going to give me negative 1. So again, I'm going to draw my slope so that it's going towards negative 1. And then dy dx at the point negative, let's do 0. 0, negative 1 is going to give me my negative 1 times a negative is positive 1 over 0. So this is undefined. So if you notice, everything on this y-axis was undefined because when x is 0, then my slope is undefined. And then my dy dx, when I have the point 1, negative 1, my y is negative 1, so I have negative 1 times the negative is a positive 1 over 1. That gives me a slope of 1. Now I did all points that involved 1, 0, and negative 1, so that's why my slopes are all 1, 0, negative 1, or undefined. But if I branched out, say I did like this point over here. Actually, no, let's do this point. If I did the point 3, 1, then I could say, okay, I have my negative 1 over 3 is negative 1/3, so I'm going to have a negative slope, and I'm going to make sure that I'm imagining that I'm going down 1 and over 3. So what would that look like? That would be a pretty, not as steep slope. I'm losing my words here. Not as steep as a negative 1. So that might look like that. I'm going to finish this slope field on my own. You finish it also, and then I'll talk about general curves and particular solutions. So I finished my slope field for all the points that were on the graph. So I have this slope field picture that's going to help me find a general curve. So a general curve would be if I took any point and I found which direction my slopes told me to go, and that's going to be a general curve. So there's many general curves. I could draw one. Maybe I'll start here and I'm going down this way. Maybe I'm going here. Maybe I'm going, any of these curves could be a general curve. But say I want a particular solution, then I have to give you a point to go through. So say I wanted the particular solution to go through the point negative 1, 1. That would mean I would start at this point and I would follow my slopes the way they were. So this is all a horizontal tangent line. So my particular solution would be that blue one. So when we're finding a particular solution, there is a way to do that with using our separation of variables techniques. And we really have like some set steps for that. So as long as we can all remember the steps, we're going to be just fine with this. So the first thing we have to look at when we're trying to find that particular solution, so I'm trying to find the equation for that red one that I drew on my slope field. Then I'm looking to see if it's separable. It's only separable if the equation is connected by multiplication. So for example, if it's dy dx is equal to 3xy or 3xy squared, that's all, that 3x and the y is connected by multiplication. So that's separable. But for example, if I have the equation dy dx is equal to like 3xy plus 6y. That's not separable because the 3xy and the 6y are not connected by multiplication. But I can turn it into separable in this case because I could say that this is equal to, if I factor out a 3y, I have x plus 2 left over. Now this is separable because the y's and the x's are now being multiplied together. So sometimes you can manipulate it to separate it. Sometimes, like for example, if it was maybe like x plus y, you couldn't do anything with that. So that would be not separable. Okay, so the first thing first, we have to determine if the equation is separable. If it is separable, then step 2 is to separate those variables. Okay, so separating the variables means I'm bringing all my x's to one side and all my y's to the other. That includes the dy dx. So dy is going to stay on one side. I'll probably divide by the y squared on this side to bring it onto this side, and then multiply by the dx on this side to get it off of this side. So I have all my x's on one side and all my y's on the other. And then I'm going to integrate. So I'm going to integrate each side separately, one with respect to y and one with respect to x. And don't forget to add plus c on one of those sides. We only need it on one side because a constant plus a constant is just another constant. But we're going to add a constant on one side. Then in order to find what that constant is, we use our initial condition to find c. And step 6 is to solve for y. Usually the hardest step because you do have to remember some algebra 2. So helpful reminders for when you're solving for y, you need log rules that are helpful. So like for example, a lot of times in these separable find a particular solution differential equation questions, they'll ask like e to the a plus b, and then we have to remember that that means e to the a times e to the b. So for example, if I have like if I'm taking e to the x plus ln of x, then that really means e to the x times e to the ln of x, which in this case is just 1, because e to the ln of x is just equal to x, which would make that x e to the x. Alright, so in this example, which of the following is the solution to the differential equation dy dx equals x squared over y with the initial condition of y of 3 equals negative 2? So first, is this separable? I'm looking for the solution, so can I do this using separation of variables? Yes, I can, because x squared and y is separable. It's connected by division. So I'm going to kind of do like a cross multiplying thing here, where I'm going to put the y with the dy equals, cross multiply here, x squared dx. I'm just separating all my x's on one side, all my y's on the other. And then step 2, or step 3 I think it was, would be to integrate on both sides. So the integral of y dy is y squared over 2. And I'm going to put the plus c on the other side, so I'll worry about it afterwards. And this one's going to be x cubed over 3 plus c. Okay, so now I have to find what plus c is, so I'm going to use my initial condition. That's telling me that x is equal to 3 and y is equal to negative 2. So negative 2 squared is 4 over 2, which is equal to 3 cubed is 27 over 3 plus c. So this is 2 is equal to 9 plus c, so c is equal to negative 7. So now I'm going to substitute that back in and solve for y. So I have y squared over 2 equals x cubed over 3 minus 7. I'm going to put that over 1 since everything else is a fraction. I'm going to get rid of my fractions by just multiplying everything by the common denominator. So I'm going to multiply this one by 6, multiply this by 6, multiply that by 6, and I'll get, well, this is going to be 3y squared equals 2x cubed minus 42. My goal is to solve for y here, so I'm going to divide everything by 3. So y squared is equal to 2/3 x cubed minus 14. And then I have to take the square root on both sides. So here I have y is equal to the square root of 2/3 x cubed minus 14. But remember, when you take the square root, you get a positive and a negative answer. Look at our initial condition. See how the y value is negative? That means when I plug in x is 3, I need the y to be a negative number. So I need to make sure that I have a negative for the square root, because when I take a square root of a number, I'm taking the square root of a positive number, which is just going to give me another positive. So in order to make it a negative number, to get that negative 2, I have to have the negative in front of the square root. So my answer is choice D, the negative square root of 2x cubed minus 14. Alright, and that's it.